of a physics class. So motion. So last video we have discussed about the distance and the displacement. So what do you mean by distance and what do you mean by displacement? So that we have learned with an example. So the object will be moving from the point origin A to the C, crossing B, and then again it will come back to the B. So what is the distance traveled and what will be the displacement of that particular movement? Okay, so that we have learned that with the difference we have learned that, and then we have learned the magnitude. What do you mean by magnitude? The numerical value of that particular quantity is nothing but a magnitude. So to understand the magnitude, I will give you this example. That suppose I will be the distance is equal to the distance from say suppose from your house to the school will be around 500 meter, right? So you have to mention that it is having some value. So that numerical value is nothing but the magnitude. So this is a magnitude. This is called as magnitude for the physical quantity. Okay, the physical quantity is distance. So that we need to mention that whether it is a 500 meter or 500 kilometer or 500 millimeter, that we need to mention that. That is called as the unit, SI unit. This is called as the SI unit. Okay, so this is SI unit, and numerical value is nothing but a magnitude, and this will be the physical quantity. So we will be denoting distance sometimes that we will be denoting by S. Okay, so distance will be denoted by S. So we will discuss that, the denotation, physical quantity, magnitude, SI unit, those things, and then we will discuss that one by one. So now we are going to discuss about. Let us go over what we are studying distance and displacement, because it is required for our questions. We have 3 questions. I had sent the answers for those questions. I'm going to explain those 3 questions now. Okay. So before that, let us learn what is distance and displacement. Just overview. Since we have discussed in the last video, just overview. What is the distance? The distance is when suppose I'm having a point A, this is the point A, this is the origin, and this is the point B. Okay. So we will be traveling from A to B. A to B, I can travel from any of the directions. Travel like this, or I can travel like this, otherwise I can travel like this, otherwise I can travel like this. These are the different paths. I can travel by this path also, I can travel by this path, I can travel by this path, come like this. Now this is also a distance. Suppose we are traveling from point A, we are going like this, and we can come back to this point. It is a distance. It is a distance. So that will be the distance. That is the length of the distance you have covered. Okay. Now let us come to the concept that it doesn't have any particular direction. So that this is also a distance. This is also a distance. This is also distance. This is also a distance. This distance is the length of the cover. Okay. So it doesn't have any particular direction. Okay. Now that is distance. Let us come to the concept of displacement. Now what is displacement? Can you call this one as this path as a displacement? Can you call this path as a displacement? We can call this path as a distance, but we can't able to call this path as a displacement, because the displacement, the meaning itself is the shortest distance between the initial point to the final point. Is this the shortest path? We don't have a shortest path than this to the point A to point B. Of course, we are having the shortest path from A to B. This is straight line. So this is the shortest path. We can't say this is shortest path and this is shortest path and this is shortest path. So this will be the shortest path. So it doesn't. It have a direction. It should have a direction. It should be having in this direction only. So we can't take in this direction or in this direction, in this direction. It should have direction. Which is having direction? Displacement. Distance doesn't have any direction. You can take this one also, this one also, this one, this one. Distance. So displacement is having a particular direction. What do you mean by displacement? The shortest distance between the initial point and the final point is nothing but a displacement. So it is having a direction. So it is having a magnitude. Magnitude of this is displacement. Here how much distance we can measure that, right? Like 500 meter, 200 meter, 100 meter, 10 kilometer. We can measure the numerical value, that is magnitude. We have a magnitude and we have a direction. It is having a magnitude, it is having a direction. therefore it is called as a vector quantity. So that is A. What do you mean by vector quantity? What do you mean by scalar quantity? If it is having both magnitude as well as the direction, it is a vector quantity. If it is having only magnitude, there is no direction, then it is a scalar quantity. So we can divide those physical quantities into vector quantity into scalar quantity, two parts. Okay. Now what is vector quantity and what is scalar quantity? Distance doesn't have any direction. It is having only magnitude, value. So that is scalar quantity. That is scalar quantity. Now displacement, it is having a magnitude, it is having a particular direction. So that is vector quantity. Okay. Now understood what is the distance and displacement. Now we will go for those questions. Those three questions. I will explain that. You have to take a new cluster and you have to write that in the new cluster. Okay. So here, like, once you have completed the lesson, then you are having questions in the class A. Here it is not like that. Part by part. Once you have studied the first concept, then you are having question and answers. You have to answer for that. Then you have to move for the next concept. Like that. Okay. Here there is a question. An object has moved through a distance. An object has moved through a distance. Can it have zero displacement? If yes, support your answer with an example. An object has moved through a distance. Can it have a zero displacement? Can it have a zero displacement? Suppose this is the initial position, point A. Okay. This is the point B. I'll be going. Okay, going to A to B, again I will return back to A. Okay, now say suppose I should return from here to here, it is 25 km. So what is the distance traveled? Distance traveled is equal to, we are going from A to B, 25 km. Again it will be returned back to our same position, that is 25 km. Okay, so totally 50 km. Okay, totally 50 km. What is displacement? What is displacement? We have started from A. We have reached to B. Again from B we have reached to A with the same path. Now we are in point A only. What it means? Initial position is also A. Final position is also A. That means what is the shortest distance between initial position and final position? There is no distance, right? It is 0. Here in this case displacement is 0. Displacement is 0. Similarly, okay, since we are having straight line motion, we don't have a circular motion. This is true for circular motion that I will explain after that. Okay, so since it is a straight line motion, point A to point B, again B to A, we will be reaching to same position. So therefore, displacement is 0. So that is possible. Distance is some value, and displacement maybe 0 can be possible. Okay, so that is about the first question. Second question: a farmer moves along the boundary. A farmer moves along a boundary of a square field. In the page number 100, you can observe that questions. First question, second question. A farmer moves along the boundary of a square field of side 10 meter in 40 seconds. Okay, what will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? So farmer moves along the boundary of a square field. He is having a square field. Okay, we should have a square field. Let me denote as A, B, C, D. Okay, the farmer will be, let us assume that he will be starting from A. He will move along a field. It is a square field of having 10 meter. According to the question, each side is having 10 meters. So this is also 10 meter because it is a square. All the sides are same. This is also 10 meter. This is also 10 meter. So totally for one round, how many meters it is having? 40 meters. So in how many minutes, how many seconds he is going to complete? In 40 seconds. In 40 seconds, he will be start from here. He will reach point B, point C, point D, point D. Okay. In how many seconds? 40 seconds. So in 40 seconds, you will be covering how many meters? 10, 20, 30, 40. So you cover 40 meters in 40 seconds. 40 meters in 40 seconds. So that means that he covers 1 minute in 1 second. Then only we can able to cover 40 minutes in 40 seconds, right? He will be covering 1 meter in 1 second. The question is, what will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds? 2 minutes 20 seconds. So 2 minutes 20 seconds in the sense 2 minutes and 20 seconds. So how many total minutes? 2 minutes 20 seconds. How many seconds we have? 2 minutes in the sense it is 60. 1 minute will be equal to 60 seconds. 60 plus 60, 120 seconds. 120 seconds plus 20 seconds. So 120 seconds plus 120 seconds is equal to 140 seconds. So for 140 seconds, he covers how many distances? For 1 meter, he will be covering 1 second. For 140 seconds, he must cover 140 meter, right? Correct? For 140 seconds, we should cover 140 meter. 140 meter distance, how many rounds will complete? For 1 round, 10, 20, 30, 40. For 1 round, we are having 40. How many rounds will complete in 140 seconds? Right? Okay. So, 140 seconds. Totally we are having 10, 20, 30, then 40. He will be covering 1 meter in 1 second. That means in 140 seconds he will be covering 140 meter. So for 1 round it is 40 meter. Second round again 40 meter. Third round it is 40 meter. How many? It is 40, 80, 120. Total is 120. If he completes 3 rounds. If he completes 4 rounds, then it will become 160, correct? But they are having 120, right? Therefore, he will be covering 3 rounds, then half a round. 40 plus 40, 80, 120, 140. So how much rounds you should cover? 1, 2, 3, then 3 and a half. 3 and a half in the sense, you will come here. This is half round, right? This is the full round and this is half round. So at 140 seconds, we will be at the point C. You was started from A, which is initial point. Okay, initial point. Now after 140 seconds, we will be at point C. Now we should find out what will be the displacement. What is displacement? The shortest distance between A to C. What is displacement of shortest distance? Is this the shortest distance? No. This is the shortest distance. This is the shortest distance and this will be the displacement. So how to find out this displacement? How to find out this displacement AC? Since it is a square, each degree is 90 degree. Each angle is 90 degree. So what is this part? ADC. ADC is a right angle triangle because square is made of 2 triangles. So this is a 90 degree. It is a right angle triangle. What is right angle triangle? ACB is a right angle triangle. So in right angle triangle ACB, okay, we know that AC by Pythagoras theorem. AC square is equal to AD square plus DC square. Correct? By Pythagoras theorem we know that square of one side is equal to sum of the squares of other 2 sides. AC square is equal to AD square plus DC square. Correct? Now what is AC square? That we need to find out. AD square, AD is 10. So 10 square. This is also 10. So 10 square. So 10 square is 100 plus 100. So it is equal to 200. This is AC square. If AC square is equal to 200, then AC is equal to square root of 200. We have learned that. Correct? Now AC is equal to 200 in the sense. Let us do it. Let us bring it to some perfect square form. Then we will write solve that. What is that? AC is equal to square root of 200. That can be written as 2 into 100 because 100 is a perfect square. If you bring 100 from out of the square root, it will become 10. Because 10 into 10 is 100. Okay. So now within the square root we are having 2. So therefore AC is equal to 10 root 2. We are having meters. This is the AC is 10 root 2. 10 root 2 is the displacement. The displacement is 10 root 2. Understood? How to find out the displacement? First we should find out how many rounds he had completed. We should find out where exactly at the end of 140 seconds, where he is exactly. Whether it will be at the same position or it will be in B, at C or B. Since he will be traveling around a square field here, he will keep on moving. Right? So at 140 seconds, he will complete 1, 2, 3 rounds. If he completes 3 rounds, it will become 120 seconds. For another 20 seconds, we will complete half of an hour. We will be reaching here. So at this point, we should find out the displacement. Displacement is nothing but the shortest distance between initial point and the final point. So we should write the line shortest path. Then we should find out that. We know that this and then base and then vertical. We should find out the hypotenuse. So we know that from the method we can find out that. Then we can simplify that so that we get the 10 root 2. So this is the shortest path and this will be the displacement. Okay, that is the answer for second one. Third one, which of the following is true for displacement? It cannot be 0. Is that true? Displacement cannot be 0? No, it is false. Displacement can be 0. I have told you in the last place. Displacement can be 0. If the person is starting from one point, if he is going to somewhere else and again he will come back to the same point, then initial and final position is same. So displacement is 0. So that is false. Its magnitude is greater than the distance traveled by the object. Is that true? That means its value is more than the distance. Displacement value is more than the distance. Is that possible? No, because displacement is the shortest path. It cannot be greater than distance. Distance may be greater than displacement, but displacement cannot be greater than distance. So that is also false. So both the statements are false. So this is about the questions. So in the next class we will discuss about the uniform motion and non-uniform motion. What do you mean by uniform motion and non-uniform motion? And we are having some activity. Then we will go for the concept speed and velocity. Again we will compare speed and velocity. What do you mean by speed and what do you mean by velocity? So we will learn those concepts in the next video. So make a note of this and write. I'll send the answers already. Write the answers in the classwork. And once school is reopened, you have to submit those answers. Take a new classwork that you have to return in the new classwork. Okay? So thank you.